Hi everyone, we're going to have a lesson today on margin of error. And when we're referring to margin of error, we're talking about the error that can occur in your data gathering. So when you start looking at bringing in data of maybe a survey and you're doing that for a sample, and then you're trying to use that data to make predictions about a larger group, a larger population that sample came out of, then you want to take this margin of error into consideration. It just helps you predict the results more clearly. So depending on your sample size, the smaller the sample size, the greater the error is going to be. The larger the sample size, the smaller your error is going to be. And that's just because the more people that you survey, if you're doing a survey for a group of people, the better idea you can get of the results for a population that came out of. Okay, so if you don't sample very many people, the error will be greater. All right, so let's take a look at how to calculate this. All you have to do is take your sample size, your amount of people that were involved in the survey, and put it into this formula for margin of error, which is plus or minus 1 over the square root of n. And n is where that sample size number is going to go. So we're going to try this. We're going to pretend like we did some data gathering on a sample size of 2,500 people, and we're going to see what the error may be on that survey. So margin of error was plus or minus 1 over square root of our sample size, which is 2,500. So that's going to give us plus or minus 1 over 50, and when I divide this out, it's going to give me 0.02. And that is the decimal version of 2%. And I know that because if I move my decimal over 2 spots, that'll give me the percentage that this translates into. So 2%. So not a whole lot of error here. If I was doing a survey of 2,500 people and I needed to use those results to plan for a larger group, what this means is there's not very much error on that. It's give or take 2% both ways of the results that I get. Okay. So let's take a look and see how we can use this in a real world scenario. All right, so let's suppose that we are going to have an election at our school for class president in a few days, but we want to go ahead and take a survey among the students to see if we can predict what's going to happen on that election. And let's say that we sample a group of 100 students and we ask them for their preference on class president, and it's between two candidates, Anna and Fred. And let's say that on the survey before the election, the results were as follows. 52% of our students preferred Anna, and 48% preferred Fred. So we would like to know, can Anna start celebrating her victory right now and be for sure that she's going to win this election in the next few days? So what we're going to do is we're going to take our sample size and we're going to calculate the margin of error, because we have to take into consideration that there's going to be some error in the survey, meaning we may not get exactly the same percentages on our actual election. So let's find out where our percentages are more likely to fall. All right. So to find the margin of error, we're just going to use that formula once again. So margin of error plus or minus 1 over the square root of our sample size, which was 100. So it's going to be plus or minus 1 over 10, which is 0.1, which translates to 10%. Okay, so we have a 10% margin of error here, which means more likely we can count on the fact that instead of exactly 52% are going to choose Anna, it's going to be more likely to fall within 10% both ways of that. So the range of students we can kind of expect to vote for Anna is going to be between 42 and 62. And what we did there was we added and took away 10%, this error here, from this original 52% results in the survey. We're going to do the same thing for Fred. So Fred's results were 48%. Taking away 10 and adding 10 to that, we'd have 38% to 58%. All right. So these are all percentages that are more likely for these results to fall in, because we have now taken into consideration the margin of error. Okay, so how can we use this to determine something about our results in this actual election? Well, what we're going to do is we're going to see if these ranges overlap at all. So on a number line, we had one person's interval of numbers falling between 38 and 58% of people are more likely to vote for one of our candidates, and then the other person was 42 to 62. And what happens is if you put these on a number line and you see that there's some overlap of these intervals, we cannot clearly project what's going to happen on this actual election because each person's interval runs into the other person. Okay, so there's some overlap. So basically, anytime you see overlap of these, when you've taken the margin of error into consideration, you cannot clearly predict the results. So the answer to the question is Anna cannot go ahead and celebrate her victory. We have to still see what's going to happen because our sample size was pretty small out of our school, so there was an error of 10%. Now, if we want to go back and do the survey again and increase our sample size, we might get more clear results, and we might want to do that until we have intervals that do not overlap so that we can clearly predict the results if possible. And that's how we use it in a real-world scenario. So this concludes our lesson on margin of error.